All right, good morning. Lesson for homework. Okay, first question. A carnival game, this is on page 34, has 160 rubber stamps, rubber ducks floating in a pool. Person playing the game takes out one and looks at it. Okay, so basically you're drawing a duck. If it's got a red mark, you win a small prize. Blue mark, large prize. So probably less blue than reds. A lot of them don't even have a mark, so you're not going to win anything. Okay, after 50 people have played, only 3 of them won a small prize. None won a large prize. Okay, estimate the number of 160 ducks you think have red marks on them. How many you think have blue? All right, so 50 people played. 3 out of the 50 won a small prize. 3 out of 50 won a small prize. So what is 3 divided by 50? And I'm just going to write it as a decimal. 3 divided by 50, or 6 out of 100, is 6/100. So based on my experiment, I would expect 60 or 6% of the people to win a small prize. So out of the 160 ducks, I'm going to take that times 6%, and I get 9.6. Obviously, there's not going to be a 0.6 of a duck, so I'm going to say around 9 or 10 ducks. Let's say 10 ducks win. Small prize. Okay. Now, how about the blue? Now I had 0 out of 50 win a small prize. Does that mean that there is 0 ducks in there? It's possible, but I would think a couple have to have a blue mark. So let's say 1 out of 50. Let's say 2% of the ducks have a blue mark. So what is 0.202 times 160 ducks? You get 3.2, so let's say 3 ducks out of all those 160 will win the large prize, would be blue. Okay, number 2, Lynn wants to know if flipping a quarter really does have a probability of a half. So she flips it 10 times, it lands heads up 3 times and tails 7 times. Has she proven that the probability is not 1/2? Absolutely not. Okay, the probability of getting a heads is always going to be 1/2. Okay, unless you don't have a fair coin. But just because it doesn't happen in an experiment doesn't change the probability that half of a coin is a head. Okay, it's still 1/2. Next page. A spinner is spinning 40 times. Here's a graph showing the fraction of games that are wins. Estimate the probability of a spin winning this game. Now, as we talked about yesterday in the lesson, it starts to even out of where the probability should be at. So this should be very close to the theoretical probability. It does say estimate, so we don't have to be accurate. But I would say it's almost perfectly between 0.6 and 0.7. So I'm going to say 0.65. 65% of the time, that game wins. Number 4, which event is more likely? Rolling a standard number cube and getting an even number. Well, how many evens are there on a dice? It'd be 3 out of 6. Or flipping a coin and landing it heads up. That's 1 out of 2. So which one is more likely? And hopefully you realize that those are the exact same thing. They are equal, both 50% of the time. And the final question. Noah will select a letter at random from the word flute. Lynn will select a letter from random of the word clarinet. Which person is more likely to get the letter E? Well, on the word flute, there is 1 out of 5 letters is an E. Lynn selecting from the word clarinet, there are 8 choices and only 1 of those is an E. Who is more likely? Should be Noah. Okay, 1 out of 5 is a better chance than 1 out of 8. This has a higher probability. All right, guys, that is it. That was a short homework assignment. We just went through all those in about 5 minutes. So that is it. If you have any questions, please let me know. Again, hopefully you and your family are continuing to stay safe and healthy. And I miss you guys. I really hope we can get back in the classroom again this year. Otherwise, you're going to have to wait till the fall to see me, and that's a long time. All right? We will see you on our next Zoom, guys, and we will talk to you later. Bye-bye.